Alright, last video of the unit. I know, it's been a long time. Now we're just looking at some applications and modeling. So, putting it all together. Alright. Okay, so from a point 100 feet in front of a public library, the angles of elevation, remember we talked about that earlier, to the base of the flagpole and the top of the flagpole are 28 degrees and 39 degrees 45 minutes, respectively. The flagpole is mounted on the front of the library's roof. Find the height of the pole. Okay, pause the video. Do it. Unpause when you're ready to check. Okay, so this is the library, as you can tell. And then the flagpole mounted on top of the library. See the flag? Alright, and so from the angle of elevation to the base of the flagpole is 28 degrees. And then to the top of it is 39 degrees 45 minutes. So this other angle right here is 11 degrees 45 minutes. Now, 45 minutes is 0.75 degrees. Or you could leave it like this too. It's up to you. It doesn't matter. Yeah, really, it doesn't matter. Alright, so I chose to use a system of equations here. Again, if you remember the law of sines from learning it sometime in your previous life, then you could have used law of sines and it maybe would have been a little quicker. It doesn't matter though, either way you should get the same answer. So first I set up an equation that says tangent of 28 degrees is h over 100. So that is with the bottom right triangle. So then from there I get that h is 53.171 feet, approximately. Then I did tangent of 39.75 degrees, because remember 39 degrees 45 minutes is 0.75, or 39.75, sorry, equals h plus x over 100. But remember, well, hold on, sorry, spoiler alert. So then I multiply by 100, tangent of 39.75 times 100 is 83.169 equals h plus x, but I know h, so I subtracted the 53.171, and I get x is 29.998 feet. So then, because this is a word problem, we want to answer in the context of the problem. The height of the flagpole is 29.998 feet, or approximately 30 feet tall. Next one, an engineer erects a 75-foot vertical cellular phone tower. Find the angle of depression from the top of the tower to the person standing on the ground 95 feet from the base of the tower. Pause the video and do that. Okay, so here we should end up with the angle of depression from the top of the tower to the person 95 feet away is 38.29 degrees. So here's my picture. This is the tower, 75 feet. Here's the person, 95 feet away. Here's the angle of depression. But because this is the horizon, or horizontal, and this is horizontal, this, which is the angle of elevation from the person, is congruent to the angle of depression from the top of the tower. Alternate interior angles. Remember? Geometry. Good stuff. See how it all comes back. Full circle. Third favorite circle. Circle. Unit circle. Circle of life. Then full circle. That's the order, I think. Alright, so then solve. Tangent of theta is 75 over 95. Theta is the tangent inverse of 75 over 95, which is 38.290 degrees, approximately. One thing I would point out, so I didn't specify on these, but we're using degrees because, again, with these application problems, a lot of times degrees just makes more sense in terms of being able to visualize how big of an angle or small of an angle something is. Alright, next one. Two fire towers are 30 kilometers apart. Tower A being due west of Tower B. We do need to know our northeast, southwest. A fire is spotted from the towers, and the bearings from A and B are east 14 degrees north and west 34 degrees north, respectively. Find the distance D of the fire from the line segment AB. Pause the video and do that. Okay, so here, the distance from AB to the fire is 5.461 kilometers. How do I come up with that? Well, so here's my picture. So here's A. It is due west of B, which means it's straight to the west. So I know that this is a horizontal line. Here's B. Here's A. Here's the fire. See, it's raging. That's why I used like an orangish color, blaze. And from A, if I look east and then go 14 degrees north, I'll see the fire. And from B, if I look west and go 34 degrees north, or turn 34 degrees north, I'll see the fire. So those are my angles. This is D that I'm trying to find, but I know the shortest distance to a line is a right angle at that line. So this is a right angle. I know the total distance here is 30. So I chose to call this x, and then this is 30 minus x. So here I did a system of equations. Tangent of 14 is d over 30 minus x. Tangent of 34 is d over x. Solved both of them for d. Did a substitution. Got all the x's on one side. Factored out an x. Divided by tan 34 plus tan 14. Typed all that fun stuff into my calculator. Make sure my calculator is in degrees. X is 8.096 kilometers. Here my calculator has to be in degrees because these angles are given in degrees. And then I take x and I go back right here and I solve for d. So I did 8.096 times tangent of 34 to d. That's how I got 5.461 kilometers. Yeah. An airplane flying at 600 kilometers per hour has a bearing of north 52 degrees east. After flying for 1.5 hours, how far north and how far east has the plane traveled from its point of departure? Pause the video, solve that, unpause when you're ready to check. Alright, so the plane has traveled 709.21 miles east and 554.095 miles north. How do we come up with that? Well, here's the point of departure, and the plane was heading north, turned 52 degrees east. So here's the airplane. See the little airplane? It's a nice little plane. And I know that it is currently 900 miles from its point of departure, because it's flying at 600 miles an hour, and it was going for 1.5 hours. So that's going to be 900. So I'm trying to find x and y. So I did sine of 52 equals x over 900. That's how I got x. That's how far east it's gone. And then I did cosine of 52 equals y over 900. That's how I got y, 554.095. And that's how far north it had traveled. The next one, this one's a doozy. So you leave the entrance to a system, that's a typo, sorry about that, system of hiking trails and hike 2.3 miles on a bearing of south 31 degrees west. Then the trail turns 90 degrees clockwise. Which way is clockwise? Okay. And you hike 3.5 miles on a bearing of north 59 degrees west. How far are you from the entrance to the trail system, so where you started, and what is your bearing from the entrance to the trail system? So if somebody was standing in the trail system, at the entrance to the trail system, which direction would they have to look to be looking in your direction? Pause the video, solve this. Unpause when you're ready to check. Okay, so I haven't solved it yet, but I drew the picture. Because if you're really confused on the problem, you can't really solve it without drawing the picture. So here's the start, and I went south 31 degrees west. So I went that way for 2.3 miles. Then I turned to the right, clockwise 90 degrees, and I walked north 59 degrees west for 3.5 miles. So this is where I am. So I'm trying to find this value x, and I'm trying to find either this angle or this entire angle, it doesn't matter which one, for my bearing. So if you solved it, great. If you haven't, now that you see the picture, pause the video and try now. Okay, so my method may or may not be the easiest way to do the problem, but it is one way to do the problem, and it got me the correct answer. And I liked it because it was very logical. I could just follow some steps and draw some geometric shapes. Okay, so my answer is I am 4.188 miles from the entrance at the bearing of west 2.99 degrees south from the entrance. So how did I come up with that? Well, alright, so again, here's my picture. Now I labeled some other things. So I called this little segment P, I call this segment Q. The whole thing is Y, so this side is also Y. This piece is W, this piece is Z, and this whole thing here is R. So I know Z plus W is R, and I know P plus Q is Y. So now I did some basic trig. Cosine of 31 is Y over 2.3. That comes from this triangle right here. Sine of 31 is W over 2.3. Same thing. Sine of 59 is Z over 3.5. That's over here. And then cosine of 59 is Q over 3.5. Also over here. So then I know P is Y minus Q. Right here. And I know R is Z plus W. So P squared plus R squared is X squared, because this green is a right triangle with the black as a hypotenuse for X. So that got me my distance. And then I know theta is tangent inverse of 0.168, which is P over R. So that's how I get the 2.299. There's my theta. Tangent of theta is P over R. And that's my answer again. Okay, good unit. Know angle of elevation, angle of depression, and understand bearings. Have a good night.